The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon to everybody. Hope everybody's safe. It's Mark from SolidCAM again. We're doing SolidCAM Live again. And I think today we'll follow up with some of the questions that were left over from yesterday, kind of a continuation of what we did yesterday. One of the last questions was reusing stock. So you can see here, we've got the same part here. And with me as always is Kevin. How you doing, Kevin?
Hey guys.
So Kevin will be looking at your questions and let me know when a question comes in, similar to like we did yesterday. But let's get started. So we've got those two parts there again. And we have the same toolpaths here. We're going to do the holes, and then we're going to do some tabs, and then we're going to wipe out those tabs. This is pretty much the same part as yesterday. I just cleaned up a few things in terms of mating the parts together. And I've actually added a 3D model for my stock. The 3D model is still the 5 foot by 5 foot, 1/4 inch thick sheet. But since we're going to be talking about stock today, I thought I would just show you how you could do something this similar. Basically, you could do this same sort of shape using the box definition in your stock manager. But if you do it as a 3D model, then it becomes associative as well. It adds a level of associativity to your part. So if the sheet changes in any way, I can just come into the original SolidWorks model that I created or the one that I added just internally here, which is what you see here. And we could just change the dimensions. And since most of the modern toolpaths inside SolidCAM are associative, it automatically will update those toolpaths as well. So anything that's looking at the stock, anything that's relying on that shape will be updated as well. So that's basically the only changes I made from yesterday. We have the same toolpaths, I just added the stock. And one of the last questions, like I mentioned, was reusing that stock. So there's a couple ways to do that. The really simple way, that is basically just the continuation of what we just talked about a second ago, is if you made a 3D model that represented that stock that you're looking to reuse. Let's say it's this one here. Let me just bring this guy up here. And if I just open this up as its own file, we can take a look at it. And essentially all it is I just took that same model that I made and I just did an extrusion of those solids. And that's somewhat easy to do from an assembly file like this one from SolidCAM External, because essentially all I did was I added a new part, and then in this part, I just created a sketch of what was left over. So I did a convert entities on this plane here, so I got the outside edge of that square, and then convert entities on the top faces of our parts, and I just got the outside edge there. So I actually got that trimmed out. Now in reality, there's probably maybe the size of the tool that I should have taken into account there. But again, this is all sketching. You could do a, let me get to the sketch window here. You can do a offset entities and then just offset by the diameter of the tool, and then you would actually have a true representation of the remaining stock. But this is just an example of what you could do to reuse that stock. Essentially, all I do is I just made a 3D model. And then in my follow-up SolidCAM part, I would just choose that as a 3D model in my stock manager. So that's one way to do it. And that's somewhat kind of a cleaner way to do it because it's easy to import that file. It's also associative. So if you want to update whatever updated stock you want to use, lots of levels of associativity there. But one that is kind of cool to use for really complex parts. This is a really simple part, but more complex parts where you've done a lot of features in 3D or even on a 3+1 machine where there's lots of different parts around a rotary. You don't want to have to model that all up inside SolidWorks. So what you can do is save a updated stock file in an STL format. What you've probably seen before in the stock manager, let me just open that back up, is this guy down here, STL. STL is a file format for CAD files. I believe it's stereolithography. I think that might be what it stands for. You'll see that file format used a lot in 3D printing, in scans, laser scans, point scans, whatever. We use that behind the scenes. So whenever you actually open up a solid verify file, you're actually looking at the STL versions of your stock and target definition. And that STL file gets updated behind the scenes every time you add a toolpath. So you can actually save and reuse that STL file. So let's take a look at what I've done here so far. So if I just check that box there, you can see that the STL file, actually once I hide everybody else, that's the STL file that actually will be saved in the background. And to save that, you can actually right click and just save updated stock to STL. And you can just give it a name. Now, I actually have done this ahead of time, so I didn't want to waste time saving and renaming files or anything. So what I've done is I've just saved this model behind the scenes, and I've opened up another SolidCAM file using these same two target models, but I'm going to use the stock from the previous file. So let's let that open up. So you see that I've shifted my Mac 1 position 1 slightly. So in the original file, the two part files were over here. Now they've shifted up a bit. So this is the idea that I'm going to reuse that stock solid. And I have a similar toolpath there. I'm just going to make some tabs on that part. What you'll do is you go to your stock definition, choose define by STL, and then just browse to your STL. So you can see I've got a couple of different versions of the file here. Let's grab updated stock from, or the askew stock from updated stock. So let's just open that up. If we click show, you can see that it's the guy there with the missing pieces. So it's almost like that I took the sheet off of I'm using the same sheet. I'm using the same coordinate system location. I'm just going to make the next second parts there. So let's just click green check mark, check the box, and oop, it came in on the wrong side. Now, this can tend to happen with STLs because of the way an STL is actually created. An STL uses the coordinate system that it came from. So there's something about this where it thought that it actually should be oriented this way. And if you take a look at a few things here, one, if you look at the SolidWorks coordinate system, the Z is pointing this way. And that makes sense because when we originally created this STL, the Z was pointing in that direction. So we know it's using the coordinate system from SolidWorks when we generated it using the updated stock. Another thing you'll note is if we go to CAM and I just highlight our origin, again, the origin is at the top corner of that stock, but it's over there, not where our Mac 1 position 1 is. So it just means that the STL was created under a different coordinate system. In the past, what you would have had to have done is maybe go back, save it as a different file, manipulate it. You might have even had to have created a dummy Mac 1 position 1. You'll see some of the older videos on our YouTube channel that reference that. But in more recent versions of SolidCAM, we actually have created the facet model editor. So if you right click on CAM part, you can go to open facet model editor, and then you can open up your file. So again, let's get a detailed view on this.
So Mark can get a breath of air here. That STL edit, or the facet model editor, was new in 2019. So if you're running a version older than 2019 and you don't see that in there, that just means you're just running an older version of SolidCAM. So if you guys want to get up to date with that 19 or 2020, they will both have that facet model editor for you.
Yeah, no, exactly. I forgot what version we introduced it, but that it's a good addition because of this this aspect here, this ability. Because STLs are very hard to work with because of just they don't like to be changed. It's this thing right here that can allow you to change the location and the orientation of the STL. If you take a look at it, we've got our Mac 1 position 1 as we set it up here. But we also have the CAD coordinate system, and that is, like I said, the one that came from SolidWorks. So what I would do with this window is I would manipulate it using these options on the side here, but I actually need to get some values, or else I'm just going to be, doing stuff trial and error. So what you could do is you can go to evaluate, measure, and I'm just going to click on the origin of Mac 1 position 1, and it gives me those values there in X, Y, and Z. The tricky thing is, what X and Y and Z are they referring to? Well, we'll get a feel for that once we actually show the stock and go and manipulate it inside that window. There is probably, to be honest, a better way to figure this out, but I always look at it as, okay, I'm just going to take these as values and then reference the two coordinate systems and then see which direction makes sense. So I've actually got a screen grab of that from when I did this morning. So I got those values there. So I'll just take this over to my other screen, close this out, hide that, and let's go into the facet model editor. I'll open up that file. So that was stock from update. I'm going to show all the coordinate systems so we can kind of see what it is that we're looking at here. We want to have that sitting on Mac 1 position 1. Now, for some reason, it looks like it's correct in here, but it wasn't when we brought it in. So I'm not sure why it does that. But if we orient it kind of similar to what we saw there, now we can take those values and manipulate this. So we want this to, see if I can kind of move this. I want this to move towards the coordinate system there in Y, but in the original one, that was Z. So in Y, we'll put this as 11.01. Let me click on the solid that we want to shift. We'll do a shift. And then in the X direction, that was negative 7.06. Both X's are in the same direction, so we'll just do the same thing. We want to shift that so that it moves in the, what was it? Let's move it in the negative X direction. So negative 706. Shift. Okay, and then in Z.
Did you want to do positive?
You might be right, because that looks like it might be over. When it was over here, yeah, probably positive. Okay, so let's do that twice. So shift back where it was, and then shift again. So that should be hopefully where it belongs. And then let's shift that in the Z direction by 250. Shift. Okay, so now we have to actually flip that because it was at 90 degrees. So let's do a shift around the x-axis. We'll do it negative 90. Nope, wrong direction. We want it something like that. Okay, we'll do a save as. And I actually have one where I did it ahead of time. I'm just going to call this one number 2 to see if I did it right. And then if I did it wrong, obviously I have it done. I'll bring in the correct looking one. We can see how I did that. So let's click OK. Let's go to stock. And we'll browse to the new STL. So fix number 2, click OK. And then to know if it's done right, we'll just show the stock. And it's wrong. I had the same issue before, and all it is just I chose the wrong coordinate system to shift it. So let's go back. And what I'm going to do is actually let's leave it as this one. We'll do a number 3. Go facet model editor. Open. Show all coordinate systems. We actually wanted to output that under Mac 1. Okay, so let's shift these again. So we want to go choose the solid, do the shift. Shift. And then if we take a look at that, yeah, we need to go down. Shift. And then we'll do a rotate around X of just 90. I think that might still be off, but we'll see. Okay, so save as.
I think you're off and by that quarter inch in Y now.
Yeah, that's what I'm thinking too. I didn't want to, let's go negative.
No, so leave that one. And wouldn't it be Y positive 0.25 now?
We're working under Mac 1 position 1.
Oh, sorry.
So,
sorry.
Yeah. So negative 2.5, and then negative 2.5 again. Let's do a save as. We'll save this as number 3. Click OK. Go to stock. And again, it's on the other window. So number 3. What did I do this morning? To prove that it works, SolidCAM Live. Okay, let's open this back up. Let me go to the one that I say is fixed. Yeah, so there it is. So basically using the shifts, you got to know what coordinate system you're working under, but once you put the shifts in there properly, you can see everything lines up now. So it's the STL stock from the previous file. And since we're showing updated stock and I have the little follower there, it actually shows what the current toolpath is going to do as well. So it can be a little confusing if you don't remember what coordinate system to output under, and that's the mistake I kept making here. But once you go into the facet model editor and choose the proper coordinate system to output to, those values, they translate in whatever axis you're working in, but those are the values you want to shift and rotate to get this. So this is actually the same STL file generated by the previous SolidCAM file, but with the proper shifts and angles to get it to line up with this coordinate system. So there's no need to create a dummy coordinate system. There's no need to manipulate it in any other way other than just shifting it around. Very similar to what you would do if you were doing any kind of mating with your assemblies. You would basically also try and line things up with proper coordinate systems and like faces and that sort of thing. So any questions on that? I don't see any questions in the panel there.
No, nothing yet.
Okay. Well, let's see what else we can do. So the other topic that, go ahead.
Before you hop on there, can you show them the other way of saving out a STL stock in the Solid Verify?
Yes. So to do that, let's go back to the other file because it actually has more solids to show how we can do that. So let's go to the original part file.
And I guess while Mark's pulling that up, the real cool thing you can do with this is you can do it on per operation as well, not just the entire stock. If you wanted just to output or save out that STL file in a certain spot, like if Mark just want to do that contour 2 and then save that STL file out just with that contour 2 toolpath in there, he can do that as well.
Yep. So like Kevin's just saying, so I just did that one toolpath. It's just doing those holes there. We can go to File, Save Machine Stock to STL, and then it basically just asks me to give it a name. The difference between doing it this way and the previous way is the reference coordinate system. I believe, and I'm not sure if they changed it, so Kevin maybe back me up, but does it still use this coordinate system if you do it in Solid Verify?
Yep.
Because I think you can see here that the one on the part and the one in the bottom corner here are facing the same direction. So It's essentially going to use this coordinate system. So before the facet model editor, I would do it this way. I would use this coordinate system, and then as long as you have a coordinate system in your future parts that matches this location, this orientation, then you could just bring in that STL exactly in its proper position. Not to say that if you do it this way, you can't use the facet model editor. You still can. It might even be cleaner to do so. But they're the two different ways. And if you're looking to just kind of not sit through your Solid Verify just to get your machine stock, then you could do it the previous way. If you have a part where you can do the Solid Verify, get a good view of it like this, maybe even remove the solids like we saw yesterday. So we got this one, this one, this one, pretty much everyone except for these ones. Just delete those, say yes, and then the remaining stock is what you want to carry with you. So this is what you can save into the future part.
Now, while we're kind of removing updated stock, Mark, go ahead and open up the settings inside Solid Verify and go to General. And at the very bottom, go ahead and select the automatic remove split solids. So what this will do now, instead of Mark having to go in there and select those split solids and deleting them out, as soon as it sees that as like a slug, it will automatically remove those. But in this particular case, since we're doing out of a sheet, it's going to remove that as well. But go ahead and just play the contour one for me. You can see now he doesn't have to go in there and remove those splits. So you guys do have that option in your Solid Verify if you guys are doing a lot of slugs, stuff like that, and you want those out of there. you can set that up to do automatically as well for your Solid Verify. Any questions, guys?
So that option was in the Solid Verify. Let's go back in there. I just saw the question before you told me about it. Solid Verify, and that is under Settings, General, and then near the bottom, Stock Splitting. You can decide what you'd like to do with it. So I originally had it set to don't do anything, basically. But the setting that Kevin's talking about is the second one. So it automatically will remove the split solids. In the case of the profile, it actually is removing little bits there. So that's why those little slugs are popping out. If I did the entire part, what happens is it leaves behind the target, which in reality is probably what you're looking to do. Because then once you do side 2 or another machine setup or something like that, that's probably what you want to retain going forward.
Yeah, and in years past, I think it was back to 2010 or 11, you would have to go in there and create a dummy program just to remove if you wanted that material out of there. And now they give you that option to remove that stuff in there. So that make sense there, Jake? Perfect.
Okay.
Any other questions, guys? We've just got a couple minutes left here, so. Is there anything else you wanted to show, Mark?
With respect to stock, other than the usual, there's analyses on how you can check for your gouges and that sort of thing. Those kind of messages will pop up automatically, but there's a lot of gouge checking in the Solid Verify relating to if your tool is rubbing on the shank, if you've defined your tool not to have enough of a cutting length and it starts to rub on the gray area of your tool definition. Let's just bring up a tool table real quick here. When you define your tool, the cutting length is this yellow area. So anything that touches this yellow area will remove material from your stock. It's recognized as cutting. Anything that rubs, that touches the gray area, that is everything outside of this, but still part of your overall length. It understands that to be a non-cutting surface. So you get those errors of arbor touching machine stock or collision with arbor and your fixture or whatever it is. So Solid Verify can be a really good tool, regardless of what type of stock you're using, to check for gouge checking with just the tools and the and whatever stock you have there. And that's kind of why it's a good idea to see if you can retain your stock, because not only is it good for things like minimizing air cuts and that sort of thing, but your tool definition, your holder definitions to see if you have enough reach on your holder. If you don't know what material is there, then that can lead to crashes. And that's a lot of the things that are related to using simulations. You want to just check this before you G-code it, before you put it on your machine, because there's things that maybe you're not visualizing because it's all 3D. You're not looking at it at all angles. Whereas the point of modeling all this stuff is that it'll check for those collisions, those interactions for us.
Yeah. Now, and I'm just kind of thinking out loud here, Mark, and I don't know if we have something set up for tomorrow, but Jake, just because I see you're popping in and out of here with that questions, which is great. When you're running let's say we're running this part, would you run multiple different parts on this sheet? Or would it just be all one part? All of the same part, I should say. Okay, so what I'm thinking maybe tomorrow what we could cover is showing you guys, so what we'll do is we have the transform that we did on this part here, but what we'll do tomorrow is show you guys how to bring in additional parts. So go ahead and show that updated stock again, Mark. So on that updated stock, so the entire left side will be these little L brackets, and then we'll show you tomorrow on how to bring in another part so you can have multiple different targets in here, all machining, all within the one CAM file for you. So we can do that as well if that helps you guys out. I think Jake, yeah, he likes that. So I think maybe we'll kind of focus tomorrow for you guys on that, on how to do multiple parts inside one operation. That works for everyone. Like I said, or like Mark said, if you guys have ideas on what you guys want to see in the SolidCAM Live, just let us know, because we'll definitely, we're just kind of shooting from the hip here, kind of getting all the wrinkles ironed out with the SolidCAM Live, but we definitely want to hear your suggestions on what you guys want to see in here as well. So send those over to Mark, and we'll get those added in there as well.
Not a problem, Jake. It's good to have questions. It's kind of like Kevin mentioned, the format of SolidCAM Live, I'm trying to keep it a little different than KevCam, where KevCam has a dedicated topic, whereas this is very similar to the way that we do training. If anyone in attendance is on training with me, if you have a topic we'd like to cover, then we do that in our training sessions. If you don't, and you just have some free-flowing question period kind of questions, then we do that as well. We just answer the questions as they come along. Hey, I remember doing this, or this didn't work for me the last time. Any kind of question like that is usually what we cover in our training sessions. So again, like I mentioned yesterday, if you're interested in getting actual one-on-one dedicated live training, you and I in a training session over a GoToMeeting where we specifically answer your questions live. Actually, you can call into the GoToMeeting and we can speak in person, sort of thing. Then just contact the salesperson for your location, your region, and you can set that up as well. But if there are no other questions, I think we have about 4 minutes left. Yeah, I think the idea that Kevin has, we could do it now, 4 minutes. What do you think, Kevin?
Yeah, it might be a little tough.
Might be a little tough. We're good, but we're not that good.
Yep.
Okay.
I mean, we could do it in 4 minutes, but to be able to, for you guys to retain the information that we show you in quick 4 minutes, it might be a little tough.
Yeah. Okay. Well, tomorrow's session is at the same time, 2 p.m. Eastern time. The link is the same, so if you've got the email, you can use it for tomorrow as well. Kevin and I will be here answering your questions. The email, just in case you guys didn't get it yesterday, let me just put it into the chat area. Incidentally, this is my actual email for everything. So if you're looking for that training, one-on-one training, you can use this as well to contact me and set up some one-on-one training. But I guess we'll end the session. What do you think, Kevin?
Yep, we'll wrap her up here and hopefully see everyone here tomorrow at the same time.
Sounds good. Everybody stay safe. Yeah, stay safe. Wash your hands. And everybody, we'll talk tomorrow.
Yep.
Have a good day.